Okay, so let's unpack this a bit. You're sitting there,
Yeah.
right? You type a question into your favorite AI chatbot, you hit enter, and then bam,
Yeah.
this response pops up.
Yeah.
And it really feels like it understands you sometimes. It's still kind of magical, honestly.
It absolutely feels that way.
So today, we're sort of pulling back the curtain. We've got some really interesting source material looking at what actually happens in that moment after you send your query to an LLM like ChatGPT.
Right.
Our goal here, our mission for this deep dive, is to get into the mechanics described in these sources, not just the what, but a little more the how.
And what the sources make super clear right off the bat is that it's definitely not magic. And it's not conscious thought like we experience it.
Okay.
The very first thing that happens in this kind of sophisticated dance is called tokenization.
Tokenization, okay.
So when you type your question, the system doesn't see whole words necessarily. It breaks your input into smaller bits, standardized chunks, really. These are the tokens. Ah, okay. So not quite words, maybe more like parts of words.
Exactly. Think of them like building blocks. Sometimes it's common words, sure, but often it's just, syllables or maybe common beginnings and endings of words, prefixes, suffixes.
Got it. So it's like disassembling the sentence first into these basic units. That makes sense for a machine to start there. And our sources say this step is pretty crucial, right?
No, absolutely critical. Because the AI internally, it only works with these tokens, nothing else.
So once it's broken down, where do these tokens actually go?
Right. So these tokens get converted into numbers, essentially. And those numbers get fed into the absolute core of the system, a massive neural network.
Okay, neural network. That sounds pretty complex.
It is, but you can kind of picture it like just an incredibly vast structure, multiple layers, tons of interconnected points, like artificial brain cells, sort of.
Artificial neurons.
Yeah.
And the sources really emphasize the sheer scale here. We're talking potentially billions of these connections, and each connection has this adjustable value called a parameter.
Billions?
Yeah.
Okay, that really explains the large language model. Wow.
Definitely. And these parameters, these billions of values, that's what the model actually learns during its training. It tunes them based on seeing just enormous amounts of text and code data.
So, okay, the tokenized bits,
Yeah.
represented as numbers, they travel through this giant network full of tuned parameters. What's the network? What's it doing with them? Our sources mention a probability engine. Sounds a bit like rolling dice.
Well, it's way more sophisticated than just dice, but yeah, that core idea of probability is absolutely key.
Okay.
The network uses everything it learned from the training data, all encoded in those parameters, to basically calculate the statistical chance of what token should come next.
Ah, okay.
Given the input tokens it got and the tokens it's already generated for the response, it's constantly predicting what's the most probable next token, one by one. That's how it builds the answer.
One token at a time. Okay. And here's something our sources really highlighted as clever, this attention mechanism. Seems important because, well, not all parts of my question are equally useful, right?
Exactly. That's crucial. The attention mechanism lets the model figure out the importance of different input tokens relative to the token it's trying to predict right now.
So it can focus.
Yeah, instead of just looking at the token right before, it can pay attention to relevant tokens way back at the beginning of your prompt, or even parts of the answer it's already building.
Ah, I see.
Our sources suggest this is vital for, understanding long sentences, keeping the context straight, and just generating text that makes sense and stays on topic.
Yeah.
It selectively focuses its attention.
Okay, so let's recap the flow. Input gets tokenized, broken into pieces.
Mm-hmm.
These go, as numbers, into the huge neural network with its billions of learned parameters.
Mm-hmm.
A probability engine predicts the next likely token. But it uses this attention thing to focus on the right context from the input.
Right.
And this just repeats, token by token, building the response. And crucially, our sources stress this isn't like a Google search, right? It's not finding answers in a database.
Precisely. It is generating language. It's using the patterns, the relationships it learned during training, what some call compressed knowledge. It's not retrieving specific facts from some index somewhere.
Compressed knowledge, I like that term.
The whole point of the training was to adjust those billions of parameters so the network gets incredibly good at predicting what token sequence is plausible, makes sense, and fits the context.
And the speed. The fact that it feels almost instant. Our sources connect that to the hardware, yeah?
Oh, absolutely. Doing all those complex probability calculations, accessing and using those parameters, generating tokens super fast, that takes enormous computing power.
Right.
Whether it's running on powerful CPUs or more often specialized GPUs or even Google's TPUs, that hardware infrastructure is what makes this sophisticated math feel instantaneous to you. It's a massive part of it.
Okay, so quick summary of this deep dive then. You type, it gets tokenized. Fed into a massive neural net packed with learned parameters.
Yep.
A probability engine predicts the next token, guided by attention to keep context, generates the response token by token.
Based on learned patterns, that compressed knowledge.
Right, not a database lookup.
Mm-hmm.
And all of this powered by some serious hardware.
Exactly. It's this really intricate dance of math, data, and powerful computers that gives you that seemingly effortless conversation.
It really is fascinating when you break it down. So, thinking about this process, how it's fundamentally about predicting the next piece of language based on learned statistical patterns.
Mm-hmm.
What would it really mean? What would it take for this kind of tech to move beyond just sophisticated pattern matching towards something we might actually call, reasoning? That's a pretty provocative thought the sources leave us with.
It really is something to definitely mull over.